All right, today we're going to concentrate on adding and finding x-intercepts. We're also going to find y-intercepts, but we're going to add that on to what we've been doing. So how many x-intercepts could we have? A lot. No, not a lot. Okay, so 2, yeah, we could have 2. But there's another scenario. You could have 1. How could I have 1? If the vertex is on the x-axis, you could have 1. But there's another scenario. We're not going to do any of them this way. So you could have none. So if the vertex is somewhere not on the x-axis and it opens away from the x-axis, we can have none. So there's 3 different scenarios of what you could have. Today in class, we're only looking at ones that have 2, because I didn't plan my notes very well. But in homework, there's some that have 1, or there's some that have 0. Okay? So if you get that, it doesn't mean you're totally wrong. It could be 3 different options. Today we're just looking at the ones that have 2 during class. So there are 3 different methods that you could use to solve for x-intercepts. And you can use whatever method you choose, but I have set this up to show you which method might be most efficient for certain cases. So the first case, you look at that equation. Do you know what form that's in? Vertex form. If it is in vertex form, or if you put it in vertex form, you're going to want to solve by what's called square roots. And to put something in vertex form, if you like this way of solving, then you're going to use completing the square, and I'll show you how to do that in our next section. But this one's already in vertex form, so we're going to solve by square roots. So to do that, to find x-intercepts or to find y-intercepts, you always make the other variable 0. So when I find x-intercepts, what do I make 0? The y, but I don't see y. F of x equals 0, and then 2 times x minus 3 squared minus 8. You probably need to write kind of small while you're doing your notes. Okay, so now what I'm going to do is I'm going to solve for x, and we want to just basically take out the outermost layer one at a time until you get all the way down to the center where x is. So the furthest thing away that I need to get rid of is the 8. So I'm going to add 8 to both sides. And then the next thing that is the furthest away is the 2. Not the squared, but the 2. So I'm going to divide both sides by 2. And then we're going to square root. What's the rule about when you square root? Plus minus. And then we're going to add the 3. We get 3 plus or minus 2. But 3 and 2 are like terms, so I can plus or minus 2 and get my 2 answers. I'm going to write my x-intercepts as ordered pairs, 1, 0, and 5, 0. You'll notice that I put it in order by the x's. So 1 is the smaller one, 5 is the bigger one. And then for our y-intercept, we make x 0. So we'll still have the side that says f of x, but I'm making x 0. So we'll write it as f of 0 equals 2 times 0 minus 3 squared minus 8. Now you do not do anything to the side that says f of 0. That is just telling you what you plugged into the equation. That means y. That side means y. So you don't do anything to that side. We just solve it for y. So we're going to do order of operations over here. Remember, order of operations, parentheses, then exponents, then multiply by 2, then subtract 8. So 2 times 9 minus 8. So y-intercept will be at 0, 10. So the y-intercept is always just plug in 0 for x. Finding the x-intercepts is the one that we have different methods for. So with question B and question C, can you go ahead and find the y-intercept? If you're ready to go on, find the y-intercept, and we'll do the x-intercepts together. The y-intercept. Yeah, so for the y-intercept, you're going to do f of 0, or g of 0, whatever the equation is. This one's f. Do for C. Do for B and C. Go ahead and find your y-intercept for B and C. Make sure we understand how to do that. Yeah, that's what you're thinking of. And I'm doing this f of 0 every time to help you learn that concept of when we're plugging stuff into the f of x. So you've seen it over and over and over again. So please don't skip that in your notes. Make sure you're writing f of 0 as well. When you get to that next course, I want to make sure you know that. All right. Example B. We are using quadratic formula. And the reason why I would use quadratic formula is because it doesn't factor. I would try factoring first. But it doesn't factor, so I'm going to use quadratic formula. So we first plug in 0 for y, and then we're going to use our quadratic formula, which we sang earlier this year. Should we sing it again? Oh, I hear the excitement in your voice. So I'm going to sing it. So it's on the recording. If you'd like to hear me sing it over and over again. So it's going to be x equals opposite b plus or minus square root b squared minus 4ac all over 2a. So we're going to do x equals opposite of negative 4, so positive 4, plus or minus square root 4 squared minus 4 times a times c all over 2 times a. And then we simplify that. And we get 4 plus or minus square root 12 over 2. When you do quadratic formula, to have it in simplest form, you need to make sure that you simplify the square root if possible. Square root of 12 does simplify. You make sure you have a positive number in the denominator, which we do have, so we're good on that one. And then, is there any number that factors out of the top? So we're going to factor that number out. And cancel it with the factor on the bottom. So you can only cancel it if you factored it out first, like greatest common factor factoring. So we get 2 plus, I forgot my minus. 2 plus or minus square root 3. So my two x-intercepts, one is 2 minus square root 3, 0, and the other is 2 plus square root 3, 0. When you do your assignment, you just choose which method either is most efficient or your favorite method. I'm trying to help you out with what's most efficient, but you really can choose whatever method you want on your assignment. The last one I do by factoring, because it is factorable, so I'm going to set f of x equal to 0. And then factor this trinomial by guess and check. Ugh. Once you have it factored, then you set each factor equal to 0. You don't just take the opposite number. It works here, but it doesn't always work. You set each factor equal to 0. You solve for each factor. And then I put it in order by my x value. So those are your three main methods for finding x-intercepts. In your assignment, what you're going to use this for is you're going to be graphing a graph. And in those A graphs, you have to find your x-intercepts for each one of them. So depending on how the equation is given to you, you can use different methods. Now, if you really like the first method, or maybe you don't, I don't know. If you like the square root method, I can show you how to put every single equation into vertex form quickly so that you can use the square root method. What's another reason we might want to put this equation into vertex form? Why? Why would it be easier to graph? Because you have the vertex, right? And then you also would have transformations if you wanted to graph it with transformations. So vertex form is really helpful. If I wanted to graph this in that form, I would have to do that negative b over 2a and then take that answer and plug it in, and I'd have to remember all that stuff. The vertex form is already giving you the vertex in all the transformations. So it's up to you really how you do it, but vertex form is really helpful. So to take this and put it into vertex form, we have to complete the square. And that sounds really familiar, like we just got done doing a bunch of that, haven't we? So that should be really easy as well. I'm going to do completing the square a teeny bit different, just a teeny bit different, because we're putting this into vertex form, and when we're done, we want it to say f of x equals. So I'm not going to do anything to the side with f of x on it. Remember how before, when we were doing complete the square, we moved stuff over like a square and like the 5. So I'm going to leave the 5. So what I'm going to do is I'm going to say x squared minus 4x. Then I'm going to leave a space where I'm going to complete my square with the x squared minus 4x. I'm going to move my minus 5 over. But if I only put one square in, that does not keep an equation equivalent, because I've just added something to one side of the equation. So what I want to do is I want to keep this equation equivalent. Instead of adding the square to the other side, say what, Avery? No, I can't. You can't have two equal signs. I'm gonna put it on the same side. So if I add a square and I subtract the square, it's like I did nothing at all. So it stays equivalent. I just added 0 to it. So now if I add, what number would go in here to complete that? 4. If I add 4, I'm also going to subtract 4, so it's really like I just did nothing. But I'm going to keep those in there, so now I have f of x equals x minus 2 squared minus 9. So I took the 4 and used it to factor here, and then I not used the minus 4 to make the minus 9 there. So it's equivalent. So now it's in vertex form as well. So what's our vertex? And we could find our AOS. We could find our x-intercept in this form or the original form. We could find our y-intercept in this form or the original form. We could find, I think that's all we need. So today, for your homework, I'm not doing all the graphs, but you're going to be graphing these. We just did that for homework last night, so you can graph it anyway. But all right, the next one, same thing. We've got g of x, and we're going to complete the square to put it into vertex form. But this one has a number in front of x squared that is not 1. So if there's a number in front of the x squared that's not 1, what do you do for completing the square? To factor it out first. So we're going to start here. I'm going to show you what I would do. I'm going to want to complete the square and then subtract the square. I'm going to want to do that, except I can't have that negative 1. So I have to factor that out before I complete my square. So instead of a square, I have the ominous fluffy cloud. Remember the fluffy cloud? It's been a while. So what do I put into the fluffy cloud to complete the square? I have to take negative 3 divided by 2, square it. That becomes 9/4. But that's different than when I put in my minus square. What do I put in my minus square? negative 1 times that number, negative 9/4. So I'll end up having negative negative on that side, which will become positive. So we're going to write this into vertex form. We will have a negative 1. We'll factor this part, get x minus 3/2 squared. Then we'll add that together, find common denominators. I've already done that. It's 41/4. So I get my vertex at 3/2 squared.
Is that also finding the x-intercept?
You can continue to find the x-intercept. I'm going to do it with the third one. I just don't want to do it for every single one because of time. We're going to run out of time. So I will, it does say in the directions to find the x-intercepts too. I'll do that with the third one. Okay, let's see. So yes, you could continue and you could find the x-intercepts from there. You could also find the y-intercepts and the AOS. All right, so is this the next one? Yeah, okay. So we're going to complete the square. So the first thing I'm going to do is I'm going to put in the square and minus the square. But I cannot do complete the square yet. Why? You have to factor out that 2 before you start. So now I have 2 parentheses, x squared plus 4x plus, fluffy globe. Out here I have plus 7 minus squared. So in my fluffy cloud, I'm going to take 4 divided by 2 squared. I get 4. But what goes in my minus square? Just 8. So it ends up being minus 8. So now we have g of x equals 2 parentheses x plus 2 squared minus 1. So there's our vertex form. So vertex is, let's do negative 2, negative 1. So it also says to find the x-intercept. So I'm going to continue and find the x-intercepts from here. So we'll make y 0 or g of x 0. We're going to move the 1 over. We're peeling away the layers. The next thing I'm going to get rid of is that 2. So I have to divide by 2. What do I do next? Square root, plus minus. So here, when I square root and I plus minus that, what's going to happen? So that's an easy one to rationalize. In fact, we've seen that one a lot when we were doing trig. So we've got plus minus radical 2 over 2 equals x plus 2. And then we're going to move the x plus 2. We're going to move that 2 over. We're going to subtract it from both sides. We get negative 2 plus or minus radical 2 over 2. So that could be your x-intercepts. I am going to combine them a little bit. They're not like terms. They're not going to all the way add together because that one's a square root and that one's not. But we also have a fraction and not a fraction. So that is the part that I am going to combine together and just make it one big fraction. So I'm going to find a common denominator, which is 2, and multiply this by 2 over 2. And so I will have negative 4 plus or minus square root 2 all over 2. So just combine it together. And then we'll have our x-intercept. Okay, when you're ready, go on to the page over. And we're going to skip ahead to number 6 or going to skip 5 for this time. So we're going to go to number 6. And 5 and 6 are the same. There's more practice. It says that we need to write the equation. It's a standard form, but I don't know. For some reason, the book calls standard form vertex form. So we're doing vertex form. Okay, so write the vertex form of the parabola whose vertex is at 4, -1 and passes through the point 2, 3. So we know a point and we know the vertex. When you look up here, what we don't know is we don't know if there's a structure or shrink. So you're going to plug in your point and you're going to plug in your vertex. Your point will be, your point will be x, and then f of x will be that 3. And then your vertex over here is going to be h and k when you plug it in. So we plug everything in and we can solve for a. So f of x is 3 equals, we don't know a, x is 2 minus h is 4 squared, and then minus 1. So you plug in both points. One is the vertex, one is the ordered pair. We can solve for a. So 4 equals a times 4. So a equals 1. Then when you're done, you just plug in your a, and you'll plug in your vertex into vertex form. And you'll have your equation. So you just have to solve for a. And then the last one we're going to do is b at the bottom. We'll skip a at the bottom. And there is some like this in the homework, but they're pretty easy. Just asking you to write the equation, one that opens up, one that opens downward, and has these x-intercepts. So to do that, we're going to kind of work backwards of when we found the x-intercepts. You know how you like set each factor equal to 0 and then solve each factor? We're going to go backwards. So these are the x-intercepts. I'm going to write x equals -5/2, and I'm going to write x equals 2. Then we're going to turn those into little equations that both say equals 0. So this one over here, I'm going to add the 5/2 over, and this one I'm going to subtract the 2. So now we have equations that equal 0. Then they're going to turn into factors as part of our equation. I don't know what a is yet. This one's going to be x minus 2. This one's tricky, though. When you're factoring equations, do you ever, like, factor and have a fraction as one of those numbers? What is it? I don't know where you're pointing.
Like the last thing that you wrote.
This?
Yeah.
We have to write the equation. We have to write the equation, and I'm writing it in intercept form, because I've just given the intercepts. I didn't put an a yet. Whoops, I put the equal sign kind of in the last one. I didn't put the a yet. So there's going to be an a here in just a moment. So this factor, x minus 2 is fine, but this one's not fine, because we don't ever factor and have x plus 5/2. We factor, and it's just all integers. So I need to do something to this equation so that I don't have a denominator. So this is an equation. I can do whatever I want to both sides. I need to still say equals 0. What can I do to get rid of a denominator? Multiply everything by 2. So I multiply 0 by 2, it's still 0. But then this becomes 2x plus 5. And so if you were going to work your way backwards and you set that equal to 0, it would equal -5/2. And you went all the way back. All right, now we need 2 equations. One that opens up, one that opens down. How can I make this equation open up? I can pick any a I want. Give me an A. 2, okay. Sorry, you weren't fast enough. That one opens up. The second one needs to open down. There you go. One opens up, one opens down, the -6 opens down.
You can change f of x to x.
Well, they're different equations, so I changed them. So your assignment is in the book. I have graph paper for you. I have changed the directions. It says this on Canvas as well. But I know like a bunch of you are going to take pictures. Just make sure I'm not in picture thing. you'll see that for the first 8, whatever you vector for, you are finding the x-intercept and the y-intercept. You are finding the vertex and the AOS, and you are mapping each of those without the calculator. And then 40 and 46 are doing vertex form, and then for 68 and 69, the directions are not changed. It's 8 graphs, and then the ones right above it, 15 to 28, those are the graphing ones. Just make sure you have all that information, and I've given you, space to do it on here, unless you write those, you're huge. And then the last 4 are just writing equations like you did on those last 2 questions. Okay.
And then I'm going to come in and send all the.
What one?
What?
Which one? I don't know.